Have you ever pondered on how the energy in your morning coffee stays the same even after you've taken that last satisfying sip? Intriguing, isn't it? This is the magic of energy conservation, a fundamental principle that governs the universe. Let's delve into the basics. Energy, in a nutshell, is the capacity to do work. It's an incredible chameleon that can morph from one form to another. When you pedal a bicycle, your muscular energy transforms into kinetic energy that propels the bike forward. Now, energy conservation is a simple yet powerful concept. It states that energy cannot be created or destroyed, but can only transform from one form to another. In other words, the total energy before and after transformation remains constant. This is known as the law of conservation of energy. To illustrate, imagine a swing. As it moves back and forth, it continually converts potential energy into kinetic energy and vice versa. At the highest point, the swing has maximum potential energy and minimum kinetic energy. Midway, it possesses equal amounts of both. At the lowest point, it's the reverse with maximum kinetic energy and minimum potential energy. But throughout this back and forth motion, the total energy remains the same. Now let's recap the key points. Firstly, energy is the capacity to do work, and it can transform from one form to another, but the total amount of energy always remains constant. Secondly, the law of conservation of energy states that energy cannot be created or destroyed, only transformed. This principle is universal and applies to all physical and chemical processes. Lastly, the swing example illustrates this law in action. Regardless of how the swing moves, the total energy remains constant, shifting between potential and kinetic energy. In conclusion, energy conservation isn't just a dry scientific principle. It's an everyday reality that powers your car, lights up your home, and even brews your morning coffee. So the next time you take a sip of your coffee, remember, you're partaking in a universal dance of energy transformation and conservation. And that's pretty amazing, isn't it?
Have you ever wondered why a bouncing ball eventually comes to a halt, or how a windmill transforms the breeze into electricity? The answer lies in the fundamental principle of physics known as the law of conservation of energy. But before we dive into the depths of this fascinating concept, ponder over this. What exactly is energy? Energy is the capacity to do work. It is the driving force behind all action and life. It exists in various forms: kinetic, potential, thermal, chemical, electrical, nuclear, and many more. Each of these forms can transform into another, and this is where our law of conservation of energy comes into play. The law of conservation of energy states that energy cannot be created or destroyed. It can only change from one form to another. For instance, when a ball is thrown upwards, its kinetic energy gradually transforms into potential energy. As it reaches the peak of its trajectory and starts to descend, this potential energy converts back into kinetic energy. This constant exchange is a dance of energy, choreographed by the laws of physics. The total energy before the dance begins equals the total energy when the music stops, even if the dancers, or in our case, the types of energy, have changed. Let's consider thermal energy as another example. When you rub your hands together, the mechanical energy of your moving hands is transformed into thermal energy, and you feel warmth. This is an example of energy conservation, but energy doesn't only exist in visible or tangible forms. There's also the energy within atoms, the nuclear energy. It is the energy that holds the nucleus together and is responsible for the devastating power of nuclear weapons and the potential for clean, sustainable power generation in nuclear reactors. Then there's electrical energy, which powers our homes and devices. This energy is generated when electrons move through a conductor. A common source of electrical energy is chemical energy, such as the energy stored in the batteries that power our smartphones and electric cars. Chemical energy is yet another form of energy. It's the energy stored in the bonds between atoms and molecules. It's the energy that fuels the metabolism in our bodies, powers our cars, and is released when we light a match. In summary, energy is the backbone of our universe. It exists in various forms, and it's constantly transforming from one form to another, governed by the law of conservation of energy. So, the next time you see a car moving, a bulb glowing, or even when you're just moving your hands, remember, It's all a beautiful, intricate dance of energy. Remember, the law of conservation of energy tells us energy cannot be created or destroyed, only transformed. Various forms of energy, like kinetic, potential, thermal, chemical, electrical, and nuclear, are constantly transforming into one another, keeping the universe dynamic and alive. So, keep this in mind the next time you flick a switch, light a match, or simply take a step forward. It's all energy in motion, a testament to the beautiful complexity of our universe. The dance of energy continues, and so does our journey of understanding it.
Have you ever pondered the intricate relationship between energy, work, power, and force in physics? These concepts, while seemingly distinct, are actually closely connected, forming a fundamental part of our understanding of the physical world. Firstly, let's delve into the concept of energy. Energy, simply put, is the capacity to do work. It is the driving force that enables us to move, think, and indeed live. Energy can be found in various forms, such as kinetic energy, which is the energy of motion, and potential energy, which is stored energy. The formula for kinetic energy is half times mass times the velocity squared, while potential energy is calculated as mass times gravitational acceleration times height. Moving on to work, it is the amount of energy used to move an object. The formula for work is force times distance times the cosine of the angle between the direction of the force and the direction of the distance. Now let's talk about power. Power is the rate at which work is done or energy is transferred. It's about how fast you can get the work done. The formula for power is work divided by time or force times velocity times the cosine of the angle between the direction of the force and the direction of the velocity. Finally, there's force. Force is something that can cause a change in the speed, shape, or direction of an object. It can be calculated by the formula, force equals mass times acceleration. So how do these concepts relate to each other? Well, energy, work, and power are directly proportional. If energy or work increases, so does power. If force or distance increases, then work also increases. If velocity or time increases, power increases as well. Force relates to energy, work, and power because it is the factor that influences work and power. If force increases, work and power also increase. Force is also a factor that influences the change in energy because force can do work on an object and change its energy. In summary, energy is the capacity to do work. Work is the energy used to move an object. Power is the rate at which work is done or energy is transferred. And force is something that can cause a change in the speed, shape, or direction of an object. These concepts are interconnected, each influencing and being influenced by the others. Understanding these concepts and their relationship to one another can give us a deeper insight into the workings of the physical world. It allows us to grasp how energy is transferred and transformed, how work is performed, and how force and power are exerted. So next time you push a door open, remember, you're not just applying force, you're engaging in a complex dance of energy, work, power, and force.